So, hello everyone. Today we're going to have an overview of solid cache, like caching in general, but more focused on solid cache, which is the new cache store that comes the default with Rails 8. So, yeah, let's get started. First of all, who am I? I am Nehama. I was a trainee in CodeMiner 42, the third edition, in July 2023. So now it's 2 years that I've been working at CodeMiner. I love reading and learning new things. I'm your typical nerd, lol. So yeah, that's it for me. I was always a nerd in school and everything, but I guess it's a good thing. And I also love music. I'm learning to play the keyboard, and when I was a kid, I played the guitar and the flute, whatever. So yeah, that's it about me. Okay, so first of all, what is caching? Like before we dive into database caching versus memory caching, like what is caching? So caching is basically a technique used to store copies of data temporarily for faster access. Think of it like your favorite mug that you use all the time. So instead of like keeping on the kitchen cupboard, you just keep it like beside your desk because it's easier and you don't have to get up all the time to go and get it. So it's basically it, like data that it's commonly used that you need all the time. Then you just like keep it in a special place, which is the cache. We'll dive into it in a little bit. And it's just like easier to get it and faster. So it reduces the time needed to retrieve data from slower primary storage, like database, for example, a certain piece of data that you need all the time. Instead of hitting the database every single time that you need it, you just keep it on the cache, which is faster. So that has a couple of benefits, which we'll see in a little bit. It's commonly used in web applications to improve performance and responsiveness because, like we said, if we avoid hitting the database every single time that we need something, and instead we just hit the cache, which is much faster, it obviously improves performance. Some examples of common caching scenarios include caching API responses to reduce load on external services. For example, feature flags. I don't know if you guys are familiar with it, but it's basically to turn on and off some features. And we hit like, so for storing feature flags or for storing like external API responses, tokens, login tokens, it's very common to use caching. Also, caching rendered HTML views to serve pages faster. So for example, if the same user already access the same page, instead of reloading everything, the whole page from the server, we just hit the cache and it's much faster. And also caching authentication tokens or session data, like we mentioned, and caching database query results to avoid redundant queries. So if we use the same queries in more than one place, sometimes we do cache that result to avoid hitting the database unnecessarily. Why use caching? We mentioned a few of those, but like basically to improve system performance by serving data quickly, to reduce load of database and web servers, because yeah, like we said, if we hit the database all the time, then it's going to cause a bottleneck. So if we hit the cache instead, it's going to reduce the load on the database and minimize network latency and enhance user experience in general. So now we'll dive into types of caching. There are two main types of caching. One is memory caching, which is the most commonly used, the most traditional one. The other one is database caching. I did a little bit of a research. Some other frameworks and some other languages do use it, but mostly they use it like as a workaround. If the caching gets too small, there's so too much cache data that you need to store that the RAM doesn't fit well. But Rails 8 is Rails 8 is leading the way in using database caching as its main way of caching. It's not traditionally used. It's traditionally used more as a workaround or as a yeah. So let's take a look at each one. So memory caching uses RAM. volatile memory for storing data. Examples include Redis, Memcached. It's ultra fast, but it has limited capacity, and it's also very expensive. Storing large amounts of data on the RAM memory is very expensive, much more expensive than an SSD, for example. And the data is lost when the server restarts because it's the RAM memory. So database caching, and a spoiler, it's basically what solid cache is. It's still not so popular, like I mentioned. It's already used in some frameworks, some languages, but it's not the default. It stores data on disk-backed databases, leveraging SSDs for faster access. For example, solid cache. It has much larger storage capacity than RAM, obviously, because it's like a small database that you use. It's more cost-effective at scale. SSD memory costs much less than RAM memory, and it's still slightly slower than RAM. And the setup is more complex, but it has its benefits. Like, I'm not here to convince you to use solid cache. I'm just here to open your mind, right? So it's not like I am advocating for it or anything. I just want to like explore the advantages and disadvantages of each. So yeah, so let's explore this. Why isn't database caching so popular? I want to explore this because it's basically all the disadvantages of solid cache are included here in database caching in general. So historically, performance constraints. So historically, HDDs and SSDs were much slower than they are nowadays. So that is why we didn't just store the caching on the database. That is why we use RAM memory. But nowadays we have much faster SSDs. So it kind of, like, in some cases it's worth it to do it. It has high read-write contentions. So if you mix cache with transactional data, it can create a bottleneck. So for example, if your application has a high database usage, and your cache is using the database, it can be a bottleneck. There are workarounds for it, but again, then it makes the setup more complex and managing also more complex. So it's all trade-offs. Memory-based systems like Redis are specialized, are battle-tested, offer advanced features, for example, PubSub and stream processing. Like, it's been widely tested and widely used. Everyone know it works. So it gives you more security. Like, using something new is always scary, right? You kind of don't know what you're getting into. So you always have to be more careful. It was usually viewed as like I mentioned, it was usually viewed as a compromise for the disadvantages of memory caching, which is the costs and the like when your server shuts down, all the cache is lost. But nowadays at Rails, it's starting to use it as mainstream because, like I mentioned, SSDs are much faster and they want to explore that. So let's dive into solid cache specifically. Now, what is solid cache? It's a Rails specific database-backed cache store. It utilizes modern SSDs to handle large caches efficiently. It's the default from Rails 8 onward. Some people are going to think that's not good. Some people are thrilled about it, whatever. And designed to provide persistent high-capacity caching. Persistent means, like we said, when the server shuts down, the cache is persistent, high capacity, because it has much more capacity than RAM. It embraces database caching intentionally, not just as a compromise. It provides scalable features. For example, sharding. Sharding is basically horizontal scaling. So you can shard binary serialization. So that means the data is stored as binary, making it possible to store all kinds of data, including Ruby objects and not just strings. So that is kind of cool. And expiry policies, so that you don't have to worry about manually expiring the data. It does it for you. So how it works under the hood. It uses a first in, first out strategy. Older cache entries are always removed first. It leverages SSD speed to minimize latency compared to traditional disk caching. So even if it's still slightly slower than RAM, it's quite fast. So yeah, it always depends on your case, right? if you still need ultra fast data, then it might be worth it to use the memory cache. But if it for example for views caching, for some other things, it might be worth it to use the solid cache. It's triggered mainly during cache writes. Background processes handle expiry and maintenance. So it means like if your cache is idle, it's not going to be triggered just for the expiry thing. It's like once you triggered it for writes, then it automatically, like, it kind of takes the opportunity to already do all the background processes, expiry, maintenance, and has quite a few configurable parameters, including max size, which is the maximum size that your in bytes that your cache store can reach. Expiry policies, for example, if you want to expire just data that's older than a week, for example, or if once the database gets too big, you also want to clean it up. So all that is configurable. Encryption, sharding and encryption are also some features of solid cache. So if you want to, for some reason, encrypt the data for more security, you can do that. And also, if you want to scale it horizontally, you can shard the database, and that's also configurable. So for implementing solid cache, it already comes with Rails 8, but if you're using like a previous version of Rails and you want to implement, so you just add it with bundle add solid cache, and then run Rails solid cache install, configure cache in config environments production, config cache store. You're going to use the solid cache store. I have a small project that I did the configuration for development, so we're going to see it in more detail soon. And then you adjust your settings in cache YAML, such as max size, max age, encrypt. There are a whole bunch of settings that you can use. So yeah, that's basically it. Sharding and scalability. Solid cache supports sharding, which is distributing cache data across multiple databases. It uses a consistent hashing algorithm, which is the maglev algorithm, to assign cache entries to specific shards evenly. And to implement, you just have to configure multiple databases in your database YAML. And benefits of sharding: improve load distribution, better performance at scale. But if you don't have so much cache data, then it's not worth it. As always, it depends, right? And expiring cache data. For expiring, solid cache tracks write operations. So like it has an internal counter that keeps track of how many write operations you did, and periodically triggers expiry tasks. So based on the setting of let me look at it because it ran away from my mind right now. But you have it all on the over here. So this is all the documentation you need. And over here they have listed all of the possible settings. So this one, expiry batch size, what determines when the cleanup job runs. So it's the batch size used to when deleting old records. It's the default to 100. And once the write reaches 50% of that, which, like, if you're using the default every 50 write, it deletes entries according to your configured parameters. So for example, if you have max age configured, it's going to delete all the entries that are older than max age. If you have max size, then it also, or if the cache exceeds size limits, for example, max size or max entries, it's also going to trigger a cleanup job. It deletes up to the batch size entries to shrink cache. It is triggered during write, so avoid slowing down idle systems. So like once you write, it triggers the cleanup job to check if so it's either once you write once you write, it checks if the write are up to the expiry batch size, then it triggers the cleanup function. And you can configure expiry to run as a background job instead of a thread. So that is also quite cool. And here's a small example. I did a basic setup to use solid cache in development. So basically in your database YAML, what I added here is the cache. I added the default and then the database storage development cache SQLite 3. I'm using SQLite because it's just a small application. And the migrations path. In development.rb, you have to use, it comes with a memory cache. You just have to change it, the config cache store to solid cache store. And in cache YAML, here is where you configure all your options. So for example, the max size, the namespace. Let's take another look here at all of the options that you can use. So the error handler, how you want to handle errors, expiring batch size. If you don't configure, the default is 100. It's to where trigger the cache cleanup. The expiry method, if you want to write it on hand, expiry queue, the max age, the maximum age of entries in the cache. The default is 2 weeks, so entries older than 2 weeks it will delete. But for example, if you want to keep it like much more recent, for example 2 days, you can also, can be set to nil. It can be set to nil, but you have to be careful, right? But this is not recommended unless using the max entries. Like you have to have some kind of parameter that's going to clean up your cache, or else it's going to go on forever. So either you have the max age or the max entries and max size, which is also going to trigger the cache cleanup. The shards, if you have more than one instance of the database, max key, and yeah, that's basically it. To configure the cache to run on a job instead of a thread, it's here, the expiry method. The default is thread, but you can use job also to run as a background job instead of the thread. And yeah, that's it for me. Finally, if you want to try it on development, you have to run bin rails dev cache to enable caching in development. This is basically a command to toggle cache in development. And then, for example, here on the views, I used, for example, this is so for using it, you use it like regular cache. It's just basically a configuration that you do under the hood. But to use it, you use it regularly. For example, here, cache the products. I am caching all of the products. And then for each product, I'm also caching this. It's not so common to use both. I just want to illustrate here that all the types of caching that you use. Also, to use one inside the other is commonly known as Russian doll caching. So it's an optimization that you can do, because like if you change one product, then if you do like if you cache each product and you change one of them, then if you cache all the products, then all the products are going to become stale, like old, and you have to replace all of them. But if you cache each one, then only the product that you changed is going to be replaced. So you can do that. And now I have an example of, I have this application here, Solid Cache Demo. It's basically, I showed you all the configurations here, and the view is basically looking like that. So let's just run the application. Okay, it's running. Let's check it out over here. So there's, like I said in the view, I am caching the product. So let's just do a refresh here. So now if we check the server, that is very interesting. We can see insert into solid cache entries, the key value key hash byte size, which is the table that it's stored. So So here we have values. Like you said, it's stored in binary, so we can store all kinds of data and insert int. So now if we refresh the page again over here, and we have a look at the server, then we can see it's not selecting from the database, it's selecting from our solid cache entries database. And yeah, so that's basically what I had for today. So just to be clear, we use for effectively using it on your project, you use it like regular cache. It's just the configuration under the hood that's different. The traditional one stores it in memory, and the other one stores it in database. And like I mentioned, there are some advantages and some disadvantages, like everything. So you should consider them carefully before adopting them in your project. And that's it for me. I hope you guys really enjoyed it, and we'll see you soon. Thank you.